Ever wondered about the different levels of software testing and their importance? This NUCIDA video explains the different test levels in software testing, which is a critical aspect of the software development lifecycle. It's the process that ensures the quality and performance of a software product, and it's an area that requires a deep understanding. Among the many facets of software testing, understanding its various levels is paramount. These levels include unit testing, unit integration testing, system integration testing, and acceptance testing. Each of these levels plays a crucial role in ensuring that the software product is robust, functional, and ready for deployment. They also help in identifying and fixing any bugs or issues that might arise during the development process. So, whether you're a seasoned QA engineer or someone just starting in the field, understanding these levels can help you improve the quality of your work. Join us as we delve into the world of software testing. Starting with the smallest testable part of an application, we have unit testing. Unit testing, as the name suggests, focuses on individual units of software. These units are typically the smallest testable parts of an application, such as functions, procedures, or methods in your code. Each unit test is designed to verify that a specific unit behaves as expected under various conditions. The purpose of unit testing is twofold. First, it ensures that each piece of your software is working correctly. This is crucial because, as you can imagine, if the fundamental building blocks of your application don't perform as expected, the entire structure is likely to crumble. Second, unit testing aids in maintaining code quality. It's like having a safety net that catches any bugs or anomalies that might creep into your code during development. When you modify your code, unit tests can help you catch any unforeseen side effects that your changes might have had on existing functionality. Unit testing is usually performed in the early stages of development. Developers write these tests as they code, which helps them catch issues early when they are easier and less costly to fix. It's like weaving a safety net as you build your application, catching any potential issues before they turn into major problems. In addition, unit testing can also serve as a form of documentation. Since each test case is designed to cover a specific scenario, anyone reading the code can understand what the unit is supposed to do by looking at its tests. Remember, the goal of unit testing is not to prove that your code is flawless, but rather to help you identify and fix problems as early as possible. It's about building confidence in your code and making sure it behaves as expected under a variety of conditions. In summary, unit testing is a vital process that helps ensure the reliability and quality of your code. It's the first line of defense against software bugs, making it an indispensable tool in every developer's arsenal. Unit testing, the foundational level of all software testing. Next up, we have unit integration testing, a step above unit testing. Unit integration testing is a key component of the software testing process. Picture this: you've got a bunch of individual units that have been tested and are functioning perfectly on their own. Now it's time to see how they work together. That's where unit integration testing comes in. This level of testing takes multiple units and combines them into a group, or an integrated system. The aim is to test the interactions between these units. It's like putting together pieces of a puzzle. Each piece works well on its own, but the real test is to see if they fit together to create the bigger picture. Remember, unit tests only verify that individual components function correctly in isolation. But in the real world, your software's components don't exist in isolation. They interact, they collaborate, and yes, sometimes they clash. And it's these interactions that unit integration testing is designed to scrutinize. Why is this important? Well, let's think about it. You might have two units that work perfectly on their own, but when they're put together, they may not interact as expected, leading to defects. These are often interface defects, issues with the way the units communicate and interact with each other. Unit integration testing is designed to catch these defects early in the development process. The beauty of unit integration testing is that it doesn't just identify problems, it helps developers understand how units interact with each other. It provides a valuable opportunity to refine and improve the software's architecture, making it more robust and efficient. In essence, unit integration testing is like a safety net. It catches the issues that unit testing might miss, ensuring that the units of your software not only function perfectly on their own, but also work seamlessly together. It's a crucial step in the journey towards delivering high-quality, reliable software. Unit integration testing, ensuring the units of your software are working in harmony. Moving on to a larger scope, we have system and system integration testing. Let's start with system testing. This is where we put on our explorer hats and venture into the vast landscape of the whole system. Unlike unit testing and unit integration testing, which focus on the individual parts and their interactions, system testing looks at the entirety, the complete product. It's like looking at a fully assembled puzzle, ensuring that all pieces fit together and create the intended picture. The purpose of system testing is to validate the system's end-to-end functionality and verify if it meets the specified requirements. It's about ensuring that the software works as a cohesive whole. It checks the system's behavior under various conditions, its response to inputs, and its performance parameters. Think of it as a comprehensive health checkup for the software system. Now let's dive into system integration testing. You might ask, isn't integration testing already covered under unit integration testing? Well, yes and no. While unit integration testing ensures that the individual components work well together, system integration testing steps it up a notch. It checks how the software interacts with external systems. Imagine your software is a guest at a party. Unit integration testing ensures that the guest is well-dressed and well-behaved. But how will this guest interact with other guests at the party? Will they mingle well, or will there be awkward silences and miscommunication? That's what system integration testing is all about. It validates that your software can successfully communicate and function with other systems, whether it's databases, APIs, or third-party services. So in a nutshell, while system testing ensures that your software is fit and healthy, system integration testing makes sure it can comfortably socialize in the software world. It's the big picture perspective in software testing. System and system integration testing, the big picture perspective in software testing. Last but not least, we reach the final frontier of software testing, acceptance testing. Acceptance testing, sometimes referred to as user acceptance testing or UAT, is the last stop on our software testing journey. It's the final level of testing before the software is released into the wild, and it holds a unique position in our testing hierarchy. Whereas the previous levels of testing we've discussed focus on the functional and technical aspects of the software, acceptance testing is all about user experience. It's here that we ask the critical question, does the software do what the end user needs it to do? And would the software support completely all business processes? This isn't just about debugging or spotting errors. Acceptance testing is about ensuring that the software meets the user's expectations and requirements. It's about looking at the software not as a collection of code, but as a tool for the user. So, how does acceptance testing differ from the other levels? Well, while unit testing, unit integration testing, and system testing all happen during the software development process, acceptance testing is the only level that involves actual users or their representatives. These users are given the software and asked to perform a series of tasks or use cases. The idea is to simulate real-world use and see if the software behaves as expected. It's not uncommon for this stage to reveal issues that were overlooked in earlier stages, simply because the developers and testers are too close to the project. But remember, acceptance testing isn't only about finding faults. It's also about confirming that the software does what it's supposed to do in a way that's intuitive and user-friendly. If the software passes this test, it's ready to be released. If not, it's back to the drawing board. In most cases, this final level of testing is crucial because it's the last chance to catch any issues before the software is in the hands of the customers. It's the user's first encounter with the product, and as we all know, first impressions count. Besides that, software suppliers initiate alpha and beta tests with key customers to get more information about their new software product before the new version is released officially. Acceptance testing represents the final seal of approval for your software. So we've taken a journey through the different levels of software testing. We began with unit testing, the foundation of all testing levels, where individual components are tested to ensure their proper function. Then, we moved on to unit integration testing, an essential step in making sure that these components work harmoniously when combined. We then delved into system testing, which checks that the entire system operates precisely as intended. This was followed by system integration testing, a critical phase that ensures different systems can effectively communicate and cooperate. Finally, we explored acceptance testing, the final frontier before the software reaches the end user, ensuring the product meets all requirements and expectations. These levels, while distinct, are interconnected, complementing each other to create a comprehensive testing process that ensures a robust software product. Remember, each level of software testing plays a vital role in delivering a top-notch software product. Therefore, software testing could be very complex, and the consequences of any mistakes that might be overlooked remain unsolved. However, the NUCIDA QA experts support you in any QM and QA-related fields like test management and test automation. Until next time, keep testing.